to introduce our next special guest, Dr. Daavid Väänänen from Wolfram Research Company, USA. So his topic is Advancing Computational Thinking Through Blended Mentoring Program. So would like to inform that you have 30 minutes for your presentation with question and answer. So the floor is yours. Thank you.
Thank you so much. Thank you so much for the introduction and having me or giving me the opportunity to present here. Thank you so much, John, also for the nice presentation before me, where he was talking about aspects of remote mentoring. So in this presentation, I will kind of continue with the same topic and discuss a program or possible programs adaptations where we can use remote mentoring, particularly discussing how we can advance computational thinking using this methodology of blended mentoring. So please, if you have if there are any issues, please interrupt me. This is a live presentation, so I can react during the presentation. And please leave questions, and hopefully this is just an opening of the discussion on these topics, as this will be a brief presentation. So it will be just an overview. So hopefully we can continue during the question Q&A session and also after the presentation. So first, I would like to start with some terminology just to make clear what we are talking about, and then moving on to explaining or giving some ideas or background on why we might be talking about the concept like computational thinking. And then the idea is to show an example, and I will share part of my journey through a project-based program where computational thinking has been applied and learned, and which is applying this concept of blended learning and blended mentorship. Then I'd like to spend a little bit time on consideration on localization and contextualization, particularly showing a couple of examples in programs in Cambodia, and maybe discuss some aspects how we would plan to move forward with this idea in Cambodia particularly. And finally, I would like to leave you at the end of the presentation some open educational resources that can be used by the teachers and the students directly to help advance computational thinking. So on the terminology, this is a concept where many people may have a lot of different precise definition on this idea. So I don't want to go into too much details on these different terminology or definitions behind it. So first, I'll just ask from the computer itself. Let's see. What is computational thinking? So that's the question. So if I send that question to the computer, it will give me an answer in a text form. It is saying computational thinking is a mental process of formulating concepts with enough clarity and in a systematic enough way that one can tell a computer how to do them. So that's one example of a definition for computational thinking. There are a couple of points that I like to make about this, that it's when we discuss computational, may think of things like computers and doing computation, but it's really focusing on a mental process. So it's a process of humans, how humans are thinking and how we can think better, essentially. And so how we can formulate concepts in such a way that we can effectively process that information and use that information effectively. So this idea kind of draws from the ideas behind things like computer science and programming, how computers function, because computers are essentially these machines that just process the information that is given to them. They follow the rules that are given to them, and then they come to a conclusion at the end. There are some advantages in applying that kind of thinking in a human processes also, whether we are navigating through the city or following a recipe in a kitchen. We want to cook something or replicate a recipe. So there might be advantages in very practical everyday life in learning how to think in those terms. So that's kind of a idea behind it. So how we can basically improve our own thinking process and then better improve ourselves and then improve the ways we interact with our communities and environments. So how we can process that? So basically, what is the way of processing this type of learning or activity? So there are several different ways how can one can approach this in practice if we draw from the concepts of programming and computation, where the machines compute information. But typically they involve these types of steps, like you have to start from defining questions. So if you have an issue or a concept that you want to think about, you have to kind of start with asking relevant questions about that. So this is kind of an approach that can be also applied in a problem solving or just and better understanding whatever is the concept you want to better understand. So you start by defining questions, asking questions related to that. Then kind of drawing in the process of this computation, you want to translate or abstract this into a form that can be processed by computation in a sense. And I'd like to say that this computation, indeed, it can be performed by a computer, or it can be, is this part of the mental process, so that you can use your brain to perform this computation or just write it on a paper and pen. So however you are actually kind of performing this computation, it involves that you have to translate these questions into a form that allows you to effectively address those questions. And then there's a process of actually computing that that form of translation. So then you want to carry out that computation to get a result, and finally you are interpreting those results and seeing if they make sense, and if you need to if that's a satisfying result, or you need to continue with that process. So one can say that this indeed is a iterative and continuous process. So you start defining the questions, you are making an abstraction or translation of those questions, you're performing the computation, then you are interpreting the results, and then you start again asking questions once you have the results and based on your analysis or interpretation of those results. And basically you can continue that process until you arrive at a desirable outcome. So that's a kind of a process of how one can or how one can also define computational thinking in terms of procedure and process that can be applied. Now, this process can be again applied in it's a general process that can be applied in several different aspects of life, but particularly one way what comes to education and teaching about well, growth of children or adults and training of educators. So the idea is how we can think better, how we can think more effectively. So this is the idea that you can apply this also in the improvement of or growth of a child, or improvement of your teaching process too. As in a classroom, for instance, you may have issues whether it's about preparing for the classes or the content of it in different subjects, but in the process of kind of going through this, that you can define the questions, you can formulate the questions in a way that you can carry out effectively the process, and then you can compute the answers and then interpret those results again. So that's still kind of in a very abstract way of presenting that. So I'd like to put it in the context of why we would be doing and thinking about this kind of thinking process. So first part of it is really kind of very just very practical, that the societies have been changing, and we have been developing new technologies over time, and we kind of need to be able to adjust to those changes that are kind of independent of us as an individual. So from the practical point of view, now we are kind of going through these different steps of industrial revolution, and we are living today in this what people call industrial revolution 4.0, where we have things like internet, we have networks, cloud technology, we have robots and automation. We are including things like machine learning, artificial intelligence. So this may sound like big ideas or big concepts, but they are actually already happening in the world. So it's not something that is new, new ideas or new applications. All of these things are happening, and sometimes it may feel like, and the reality is that it hasn't reached everywhere yet. But if we look at the past and we look at the acceleration of this development, things are happening very quickly. Even in Cambodia, we can see that there's a big difference between living in a city or Phnom Penh versus in outside of the cities. But these things are happening actually very quickly in if you look at the cities, and it's also expanding gradually outwards of the cities too. So there are a lot of issues what comes to accessibility of technology and so forth. So I'm not going to go into those. We can discuss and it has been discussed in the other talks. But this is kind of preparing ourselves for the future, the kind of reality of today, and also kind of what are these kind of thinking processes that we kind of need to have in order to navigate in this kind of world where we have all these different types of technologies. And as I mentioned, that this is something to prepare for now, kind of from the cultural and social needs point of view, from workspaces and work opportunities, but kind of predicting further down line in the further to the future. We can think of if this what is happening in this industrial revolution 4.0, we have internet, we have mobile devices, we have concepts like virtual reality and artificial intelligence. So if we start putting all that together, then that kind of we can predict that this kind of automation and computer assisted automation will become even more prevalent in our societies. And I'd like to quote one of the studies where they say we have to be looking at how we train our young people and reskill workers so they are ready to move into roles that technology like AI, artificial intelligence, will create. So we need to emphasize the importance of increased investment in lifelong learning and retraining. So this is part of preparing our future generations for the future, but also considering that the world is changing around us kind of independently of us. So how we can make sure that everyone has a role in the society and we can together contribute to society the best possible ways. So in order to navigate through this kind of changing world and with all sorts of things happening around you, both from the technology wise, the technology advancements, but also kind of having this discrepancy of people having access to technology and many people not having that. So kind of in living and navigating through this kind of complexities in the world, people have come up with this kind of concepts of core skills that are actually kind of needed to effectively be part of the society. So one example is this 6 C's of education for students and society, and also for practical well-being of the individuals and well-being of the society itself. So that includes concepts like character education, so considering ethics and morals, being part of as a person, being part of bigger communities, being able to communicate with each other effectively, be able to think creatively and critically, and approach problems efficiently, and be able to collaborate with others. So these are kind of a basic foundations that on top we can build any kind of knowledge and applications that we might need or want to have in our lives. So as we noted, these are 6 C's already, but this doesn't include the 7th C. So one could, we have been discussing the concept of including as a 7th C computational thinking. So these 6 C's provide kind of this foundation on top of we can build, and kind of the 7th C here will give these tools on how we can address these issues that we have from kind of in an effective way, whether it's about approaching any of these issues which may come with communication or collaboration, or advancing or understanding the technologies that we have access to or we would like to develop it for further improvements. So that was going from what is computational thinking and why we might discuss it. So for the rest of the presentation, I'd like to focus on very briefly on one example how we can and basically apply this process. So I will actually show you examples of from summer programs that I have been part. I've been happy to be part with Wolfram research, organized by Wolfram Research. So they have annual summer programs that that have been physically in the past held near Boston in the United States. And essentially it has 2 types of programs. One is what is called Wolfram Summer School, but it is really a career and educational opportunity kind of for professionals in the fields of science, technology, innovation, and educational innovation. So this is really kind of focusing this aspect of mentoring educators or providing career opportunities for educators. So this includes also scientists, technologists, and business people, and also innovation in the field of education. So the concept of this summer program is that it starts with kind of addressing this processes needed in or including the processes in core competency skills that are core skills, those 6 C's and its 7 C's. So you are assigned a project or you are ideating on a project at the start of the program. And you have the opportunity to discuss with the leading experts like Stephen Wolfram himself. And then you will be assigned a mentor who will be with you throughout this program. So this is an in-person program. This has been an in-person program annually that lasts for 3 weeks. So it's kind of a very intense program where you go through this whole cycle of ideation, coming up with the idea for a project, been working with expert mentors and on one-to-one relationship with your mentor, and then having kind of self-paced lectures that support that. Well, there's a structure for lectures that support that you can attend, and then self-paced learning where you can time where you can find more information and work on the project and a problem. And then finally, you will be presenting that those results at the end. And there's a similar concept. You can maybe just study it for the high schoolers. So a summer camp idea. So similar ideas of the project of ideation, assigning mentors, and working on problems and projects that involve some kind of this 4-step process where you define these questions, you translate or abstract them into a form where you can compute them, and then perform the computation, and finally interpret the results and present the results. So these are just some examples from the high schoolers what kind of projects they've been working on. So you can look at yourself on these web links. They will be available. So basically, you can be asking these whatever questions might be interesting or of importance to you, and then actually delve into details of how you can answer or address those questions. In this case, this is using some advanced computation, but it depends on your level and the problem itself, what kind of level of advancement in the computation might be needed, or type of computation might be needed in order to address that particular issue. So I won't go into much more details into this. We can look at them also afterwards. More, see, just checking on time. You see, we are approaching the end of it. So I'll just maybe finalize with some ideas on how we can, where we were discussing kind of professional development for professional as a career development, and then adaptation for high schoolers. And we're also working on ideas how we can kind of integrate that into also earlier education. So that's something that I would like to, maybe we can discuss more, but the kind of the concept is similar, but then we can have a different structures, more continuous structures, not just summer camps that can be then blended into the idea of ideas of I will just mention that we have run some pilot examples here in Cambodia, and we have worked on different examples of with the high schoolers, which we're then working on creating projects like creating mazes and creating like these virtual environments where they can start ideating and actually working on some kind of ideas. So those are some examples I can also show or discuss later on about the contextualization. So this is a big issue and discussion on its own when we discuss localization and contextualization, which will involve, again, those issues that were mentioned, like language or cultural consideration or accessibility to technology and so forth. So that's a big thing. So we can have a more elaborate discussion on that that topic. So finally, I just want to leave you with some examples or some open educational resources, online-based resources. So there are some websites that provide more information. There are some, I showed those examples of computational projects, so you can kind of start learning through this kind of open tools. So at least those who are following this are following through internet, so you will have access to this type of things. So for instance, the programming lab is an example where you can just kind of explore without much prior knowledge on the topic. So you can just kind of click, and then there are some prompts and questions, and then you can just, by clicking at proceed this. So it's kind of doing the process of there are some questions, and it's been kind of doing some part of the work for you. So there is a piece of code already given, and then you can kind of, and there are many topics that you can then look at. And there's a list of other tools we can share that in a chat room, or you'll have access to from the presentation, or we can have more discussion on the forum also afterwards. So I'd just like to leave them with this, so we have a few minutes for questions, and then we can continue those afterwards also. And so please also send me messages, so then we can continue also outside of or after this conference. So I'd like to just quote at the end the Wolfram brothers. So one part of computational thinking is that it's kind of this magic in optimizing how this process, computer and human, can be put together to solve kind of these increasingly more challenging issues that we are facing in our lives and in a society. And by Stephen Wolfram himself saying that it will be a defining feature of the future, and children need to learn it now, and so that they can ensure success later on. So on that point, I just want to say Stephen Wolfram himself will be giving a talk, so he will be going much deeper into this topic. So you can also ask questions directly from him tomorrow at 9:45. And he's giving a presentation and during plenary talk time about the future of computation and its opportunities for students and teachers. I think we might have time for maybe one question, but again, I'll be available later on, and we can continue the discussion also after this. Thank you so much.
Thank you so much, sir, for your wonderful presentation. So now it's time for question and answer. You still have like 5 minutes for this section. So the first question is, what is application from Mr. Emperum? What is application in Wolframs? What is Wolfram play important role in mathematics teacher? So please.
So Mr. Turret, again to precise again. So what is application in Wolfram? What is Wolfram play important role in mathematics teaching? So that's especially when we're discussing mathematics teaching. So that's perhaps what we go into this software or itself, and we discuss the Wolfram tools. Then indeed we have been applying it. Like let's say the first example, even on this, would be doing like a mathematics calculation using it as a tool to perform kind of this mathematical computation. So indeed, that's a very effective tool in order to do this kind of thing, and that kind of allows you to perform some of these computations that that may be challenging, and this allows you to kind of move. These types of tools allow you to let's say if we are going to do some kind of calculations that will allow you to perform this type of perhaps more complicated calculations, and let them machines and computers to do that can use them more effectively. So this is more perhaps in the idea of when you are addressing projects and problems. So let's say we talk about these bigger picture things that you have a problem that you need to address, whether it's about growing food more effectively or sanitation or hygiene related things, or air quality, so improving your health and the health of the communities. So there might be aspects that in order to make, let's say, improve the air, your breathing in the cities, for instance, and you might want to build or have air quality monitors, then you have to kind of approach this problem. So how you can actually do that, what are your resources, kind of go through that. So in this kind of problems, this computational thinking process is actually helpful. And then it's a part of that you actually need to build those devices, and that may require some aspects of computation and even mathematics, that it's not really necessarily the point to learn about that part of programming or mathematics, but you just want to get the outcome in order to have that air quality monitor at the end. So some part of that can be then done more effectively using the help of this kind of tools and this kind of process. So that said, we can also use it as a tool for this kind of subject-specific items, but I think the best opportunity is really in this kind of projects that apply and integrate different subjects.
Thank you. So another question from Mr. Sarat. So the question is, could it be challenged to mentor or mentee when they might not be clear with this blended mentoring program? So how can you promote this program to be well known to the user of those programs, especially in Cambodia context?
Right, that's so that goes to this discussion on contextualization, and indeed there are challenges that are specific to specific locations. So when maybe the concept of blended mentoring itself, so the idea, I didn't go into too much details, like John Edmonds discussed remote mentoring and using like Observic tool to do carrying out more effectively the remote mentoring. So the idea of blended mentoring is, I have some ideas, so kind of building up on blended learning concept where you have in-person training and then kind of this remote part happening in the learning, and then the blended learning is that partially part of it it's happening in person, part of it is happening remotely. So kind of the mentoring, blended mentoring is the idea that you have also partially it happening in person. You would have this face-to-face connection with your mentor. Excuse me. And then part of that mentoring would be perhaps remotely using a tool like Observic or just exchanging emails and so forth. Or it can be just over a phone call and things like that. So that's just to clarify this concept, an idea of a blended mentoring part of the program. So that's a methodology or idea that is independent of the concept. So you can apply that mentoring process not just to computational thinking, but in other topics as well. Obviously, so when we are discussing this type of program that I discussed about the computational thinking that applies this blended mentoring, then there are these challenges of accessibility, so how we can reach people, not just in the cities, but also in other places. So the ideas that could be that we have some programs already that are providing community-based solutions. So you have access to more, like in the community, you have a space where people can come together, and there can be books, it can be a library or some other place where people can come together whenever they have time. And during those kind of places, one can have these types of programs, so they could have some resources. And I was discussing kind of very advanced resources, tools, but you can actually have this type of even learning about computational thinking. You don't necessarily even need computers, so you can have play-based approaches, and then you could have mentors in these kind of communities where you can meet them face to face, and then you could also connect to them, let's say, remotely, either using Zoom or Observic or emails. So that those are some ideas that could be put forwards, and also in Cambodian context. And I see that just quickly that indeed there is an offline version of the tool. So I was using, these are examples of online tools, but you can also have the desktop version, and particularly there is this type of small computers, microcomputers, that comes with the actual pre-installed version of that can be used offline. So these are actually available also, well, here in Phnom Penh at least you can find it in stores. The advantage is there is a price to it, but the price of that is actually smaller or less than having a full-scale computer.
Thank you so much for your wonderful answer. So we have another question. After we publish document with verified account, does the link is still usable after our account is disappeared?
Okay, so that goes into the details of these example tools that I have shown. So this, if you're referring to this program, so this particularly itself, you can kind of just use it through the online version. So this part doesn't require signing in or registration. So you can kind of try all these examples, and then, but indeed, if you're just trying without registration, then it won't save it. So you can come back to it and start over. But there is an opportunity to create an account, and there are some examples, like we have access to online tool, Wolfram Cloud, which is a kind of a complete set access tool where you can use these resources in its entire form. It comes with some different subscription models, but there is a free basic plan where you can also save to your space. That comes with the caveat that it will be safe for 2 months, and after that the space is emptied. So if you want to keep the storage, you will have to pay some subscription basically to keep the storage, but you will have access to full product. Maybe that's okay.
Yeah, thank you. We have the last question. So can Wolframs used in offline?
Oh, I think yes, thanks for that. I mentioned that indeed, so these are the online tools, but there is a desktop version that you can actually download on your computer from the website. To fully use that feature, that does require a license, purchase of a license. You can try it. It's a free trial, but kind of it's had very extensive features, and it's actually quite powerful tool. So that's the model of being able to sustainably support and provide these resources. So that's for individual use, or if you then it does require a license. Many universities already have license, and that's what we are discussing also in Cambodia. If we can have through public sector also would have access to this in more widespread manner. As I mentioned, this Raspberry Pi computer, microcomputer, comes with pre-installed version of it. So that's one way of getting a full access to and playing it. The processing power may not be as much as in the high-end laptop computers or high-end desktop computers, but it's much also a cheaper price point that you can, with this available also in Phnom Penh. So that's a way of accessing it offline too.
Yeah, thank you so much. So I said it was the last question, but however, because you are the last one, so yeah, we are happy to discuss more a little bit. So this is really one last question for you. So the question is, what is different between Wolfram's mathematics and Wolfram alpha?
That's actually, it's a good question. Most people might, or many people might, Wolfram tools from Wolfram alpha. So probably the one who is asking the question is already familiar with it. And this is one of the examples of the free online tool. So you can ask the questions from here, like having, it can be a computational question, like I'm asking 2 + 2, but you can see that I'm actually writing it in terms of letters in English. So I'm actually asking the question in a written format, and then there's a lot of things happening underneath, and it's translating it into this computational form and performing the computation, and then showing different ways of illustrating the answers. But indeed, so this is a Wolfram alpha, just for those who have not been introduced to that before. So this is this computational query engine. So you can ask question, it performs the computations and shows the result. And you can kind of, it works, you can like a search engine, but the difference kind of between a typical search engines is that it actually performs the computation and shows you the result rather than searching the result from the internet that the typical search engine do. So it's not a search engine, it's a computational engine. So that's why you may not be always able to compute everything, but what it can compute, what is in the form of a computation, can be formulated in the form of a computation. It will actually compute it. It's not going to search for it from unverified sources, for instance. And so that's Wolfram alpha. So what is Wolfram Mathematica, or so that's the actually product that is, you can then yourself basically create tools like Wolfram alpha. So Wolfram Mathematica is built on this programming language, actually, which is called the Wolfram language, that was developed or is developed by Stephen Wolfram and the company. And so Wolfram Mathematica gives you effective access to this powerful programming language that can power tools like Wolfram alpha. So for instance, Wolfram alpha, or these types of resources that I showed are applying this Wolfram language, and this is essentially an example of how Wolfram Mathematica looks like, and how you can type or have computational programs running, and even go as far as doing simple things like simple computations, and then advancing into more advanced features, and all the way up to you could build your own Wolfram Alpha in a sense using this tool. So that's the main difference. So Wolfram Alpha is this query engine that is applying Wolfram language and these computational processes, and with Wolfram Mathematica and Wolfram Cloud or Desktop tool, you can actually create yourself those computational create yourself these computational knowledge and computational tools yourself.
So thank you so much, Dr. David, for joining us today and sharing such a very interesting and useful topics for all the participants. And we appreciate you so much that you spend more more than the schedule that has been set. Yeah, we're so grateful and happy with you that you can share a lot of things today. And we hope to see you next time.